Alright, hi again. So this video today is going to be mainly on light. Now don't worry, even though I'm a physicist, I'm not going to bore you with the wave theory or the particle theory. I'm just going to talk about light when it comes to photography. Now there's a couple of things you might want to know. What is light? What you really have to be able to understand how light functions when it comes to photography. Now this is the exact opposite to printing, the printing process. Take a sheet of paper. Paper is white, yes. And to make the colors appear to it, you're gonna put ink on this piece of paper. To print black, you're going to have to put the black on the piece of paper. If you want to do white, you don't do anything. You leave that spot with nothing. You don't put anything on it. You're not going to spray it with white ink. Anyway, what this has to do with photography is the fact that photography, it's the exact opposite. When there's no light, everything is black. When there's lots of light, everything is white. Now light is composed, here I'm going to go on a little scientific side, light is composed of mainly three colors. Those three colors being red, green and blue. Each little pixel on a screen or something, one pixel, every one of those pixels, if you look really close, if you spray the screen with water or something, you'll see thin lines of red, green and blue. And actually what happens is the fact that those three stripes of red, green and blue, when they're pushed that close together, given different amounts of green, red, blue, you get an entirely different color. Now you'll get red when it's only red and green and blue are switched off. You'll get white when they're all turned up to their maximum. You'll get black when they're all turned off. It all works that way. Go ahead, spray water on your screen. It won't damage the screen, you'll just see red, green and blue dots. Now where this comes into photography is that basically anything that has color, take this magazine. Now I'm not going to do any propaganda for Science et Vie, but it's a very good magazine, and again, no, I'm not a nerd. This is just, yeah, doesn't matter. Anyway, these colors, okay, take the paper, it was white originally, there was ink printed on it, red ink, black ink, green ink, etc. Now what this ink does is, basically it absorbs different parts of light and reflects other parts of that light. When it's black, it absorbs all light and no light is bounced off. When it's white, it doesn't absorb anything and it bounces off all the rest. Green, it's more complicated, it just bounces off the green or a little bit of redness, if there's some yellow, it doesn't matter. Anyway, what I'm trying to say is that the camera, when it captures a picture, say of a red screen for example, what's going to bounce off the red screen is going to be the components of that light ray that make the light red itself, and then are going to be bounced onto the sensor. Where does all this come into what I'm actually trying to say? Now what I'm trying to actually say is that for the picture to be printed on the sensor, light is going to have to enter the lens and arrive onto the sensor. There's different ways to control how much light, there's different ways to control how much the sensor reacts to this light. I'll be covering those in future episodes on exposure, aperture, shutter speed, sensitivity, yeah. And so yeah, that's mainly what you have to understand about light, is the fact that it's extremely crucial when it comes to photography. If there is no light, there is no picture. Light needs to be able to enter the camera and then be printed onto the screen. And that's pretty much what I have to say. and I'll catch you later on my next episode, which I still don't know what it's going to be. Yeah, we'll see. Anyway, in the meantime, why don't you just hit that button that says subscribe and give me a thumbs up, leave me a comment, and I'll see you next time. Alright? Alright, see you guys.